Sorry for the delay. Uh, Thank you for the invitation, and it's my pleasure to. Can you hear me well on the mic? Can you hear me? So, on behalf of myself and our small organization called Never Lang Organization, I have a pleasure to present a language which we developed for past few months. So actually, that's the name of the language, Never. So I thought that I will never write the programming language. So after that, well, still I was thinking that it will never happen. But eventually I was advised by a nice person to start doing something. And then I thought that maybe I will start. And surprisingly, after I began in April, and we have February next year, so it's less than about 10 months past, but I'm here to present the language. So in this agenda, I will talk about the motivation, which will let me here. It's just a side project, and about the design, the decisions, what's under the hood, and I will make a small demo that the language is actually capable of doing something useful. Because many languages start with Fibonacci or doing some temperature calculations. I have this also in my language. So as I said about the name of the language, so in this picture you can see that all the letters from A to Z were already taken. There are many names of ex-girlfriends, I think, like Lisa or Lily, so that was also I couldn't use. And there are many names of famous scientists and some cute animals, so that I thought that, well, never also will fit as well, so that's the name. So it's a hobby project, a creativity escape. I also am learning a little bit about programming languages. It interests me a lot. I think that many people who work in IT or computer science, they also are interested in this because this is their primary tool for doing things. And in the background, you can see this is a translation to Polish of the Dragon book, which I was reading, and that was the kind of one of the first book which gives you some very theoretical background. Then there are two books which led me to extend the language. There was a talk about types, so we have also a book about types, and there is a book which was very useful to start doing actually the design or the language, not from using the Dragon book, but rather to start writing through a machine. And this is a perfect code. There are some clean codes. So those are the things which you also should look after, not to create some mess, but some maintainable code which can be extended. So the design decisions, this is first I began the language as a functional programming language. There is a chapter in the book how to make a functional programming language. And then I decided it should be called by value, it should be statically typed, because I want to have the compiler to correct my code, and besides such code is faster. I knew that many functional programming languages are ML based, maybe you know OCaml, which is very hard to read. So I then thought if everything is doing from scratch, then maybe I can have some C-like syntax. And then we have reference model, so everything is reference, basically. We have box values, how the values in memory are represented, so every float or integer or string is kept inside the memory as a separate object. And it's syntactically scoped. So under the hood, what helped me a lot was actually not to come up with something completely new, but I read the book which I mentioned before, and then there I found the malware machine. I suppose it is the basis for the OCaml language. It's virtual machine. I also needed mark and sweep garbage collector, because how the objects are created, how the first class functions are being returned from different functions. So not to have so-called spaghetti stack, I needed a garbage collector, which also kind of simplifies things as minimalism matters. And tail-rate optimization, when we have a functional programming language, then we don't have loops. But using tail recursion, we can change loops into functions. Then there are some other things like hash maps, trees, linked list, and everything is written in C using our old friends Bison and Flex. So this is kind of the basis for many compilers when they are in the initial step. So that's how a typical code looks like in Never language. So here we have static types. It means that the function calc returns a function from within it returns a first class function. This is its type, that it takes a float parameter, returns the float, and it converts Fahrenheit degrees into Celsius. So we get a function, and then we call it with some parameter, and then get a value. So that was the first part which was written. And okay. So those the language, how it was developed, I decided to first begin from invoking functions, because many programming languages have loops or ifs, conditionals, or some other control structures. But this seemed to be not very interesting to me because it's very well written, and all the function invocations are written in a textbook at the end of it. So I decided to begin from the end because the beginning was not very interesting. And actually, I think that was a wise decision because this way I had some kind of structure how the program will look in the later on, some framework I could extend. So everything was expression, also functions are expressions. We have some simple operators, and we have only one type. And that was the beginning, so to execute some expressions. Then I thought, oh, maybe having these controls is not enough, so I added a type integer, so I could add a new operator. I could do some Boolean expressions like and or not. And later on, I thought that, oh, maybe we should add something more. So let's go back to some controls, and I added some arithmetic functions and also assert function. And that was also, I think, a good decision because this led me to write programs which were validating themselves. So when I would write something in the Never programming language, do an assert, and then I knew that if this program works, then this assert will pass, and that I can create a large test suite of many tests to validate if what I'm doing is proper and if I'm extending the language in a proper way. So then I got back to types, so matrices again, as to do something more, and those were conformant arrays. Conformant arrays mean that when you pass a function, an array to a function, then you will get its dimension as an argument of a function. And such solution is in the Pascal programming language. I also overloaded operators. Then I thought, oh, maybe let's go and add some more control flow. So I added 4 while loops and also variables. So this and this point, it's also interesting because I was trying to write some dynamic programming language. Maybe you know dynamic programming some problem to solve, and it was cutting rod. You maybe know that you should get a maximum value when cutting the rod, and there are some values which you should remember. But without side effects, it was very tedious to write such a program. So I thought, oh, let's do some assignments. It was to be a functional programming language, but maybe if someone doesn't want to use assignments, he or she will have still functional programming language. But if we can change something that we can do more easily code some interesting problems. Then I added types and exceptions. And that's it. So So that's how the programming language was progressing.
Could
Yes.
you tell more about exception? Why you decided to implement this model of exceptions and not something else?
Well, I also was thinking how to handle with some runtime errors. Okay, the question was why I decided to add exceptions, not some optionals or some other form of error handling. So that's because if we had a division by 0, then the virtual machine would stop, but I didn't want to do that because I would like to have the programmer to have a chance to handle the situation in his or her way. So I thought that, oh, maybe there is something like exceptions, and I can learn how to do exception handling. I learned that exception handlers are being searched by binary search in the code, so that was really a surprising technique, which I also found somewhere. And yeah, that's how I added that. Here you can specify only the name of the exception. There are different exceptions like array out of bounds or some others. So how much time do I have? 5 minutes and then questions. Okay, so here I have an example of a neural network. So briefly, I wanted also to make some example of some more advanced program. So this is backward, forward propagation of the supervised learning of a neural network. We have a perceptron, we have some input values and some output value. So yeah, and also some neural networks are recently a hot topic again. So basically, we want to set those values to such variables to such values so that the error which is returned by the perceptron is as low as possible. So basically, we need some function which gives values from 0 to 1. We wanted to have a randomized function. Here we have a seed, and then we return our linear congruential generator, which gives us subsequent pseudo numbers. Then we wanted to define our own multiplication. We can multiply arrays in another language, but we want to have some other form of multiplication. So here it is. So this is kind of element by element multiplication. So those are the input values. We have here we have 4 out of 8 possible values, and then expected outcome which should give us the neural network. And as you can see, the output is the middle value, and the left and right column should be discarded. So then we begin with some random values. For all input values, as those are operations on all elements of an array, we get some output, which is the S. Then we use something, and then we have output of our network. But we want to improve it, so we use something like called in the back propagation. This is gradient descent method. Here we have the sigmoid, its derivative. So we want to move towards minimum of the function. So we calculate the error, then do some multiplications and correct the coefficients of the network. So all those operations on matrix are done in some convenient way. You needn't to write how to multiply some matrices. Everything is executed by the virtual machine. So matrices are first class. And in some many learning cycles, we repeat the forward-backward propagation to have those coefficients low. And here are the results. Those values are in bold are the input values which the network has never ever seen, but it gives us proper results, except for one value where it's undecided. Instead of saying that it should be 0, it gives us value 50, which is, well, kind of unexpected value or some undecided value. So that was the longer example. And in the future, I want to extend on types, add some operations on lists, use some externals, and improve runtime. Actually, records and list comprehension and foreign function interface have been added since I wrote this presentation. So yeah, I think that I will now focus on some type inference. I think this is what Lua people want to do. And basically, that's it. So to summarize, creating programming languages is fun, can teach you a lot, although it comes at the price. And I think at the end is satisfactory to see something that it's running and that it's being executed as you expected. So thank you very much for your attention and for invitation. And if you want to check the language, you can visit the website. And of course, I like to, if someone starts me on the GitHub. So thank you a lot for your time. Thank you very much. If you have any questions, and if I have time, then I have T-shirts for the best questions, for 6 best questions. Yes, a question.
Yeah, so you're doing pass by value, first of all.
Yeah.
You also have references and box values. So if you pass like a big value into a function, does it receive a copy of the entire structure?
No, it's by reference. So you get only kind of a pointer or a reference. So only a reference is passed to that value. If you have an array, it's still in the memory. It's not being copied.
All right, but all values are immutable memory.
No, you can modify them by the assignments. So if we have a reference to a variable or index an array, then we can modify it with assignment.
And that modification will also be visible to the column.
Yes.
Why did you choose to both have loops, like in C or
Uh-huh.
other imperative languages, but also have tail call optimization?
Yeah. Well, I think that it's your choice if you prefer to do this way from some academic point of view, or if you would like to learn how tail recursion works, or if you would like to try to write your function in the tail recursive way, then here you go. You can try this. And if you are, and loops are syntactic sugar over tail recursion, so you can do tail loops instead. And another question?
So arrays is first class citizens, right? Operations on arrays, right?
Yes.
And I'm just wondering, when it's compiled to binary code, it's compiled to binary code, right?
Yes.
And do you use some optimizations, you know, this single instruction, multiple data, maybe?
No, not yet. But I thought that using foreign function interface, I could use some libraries to do such optimizations, but it's not ready yet. Yes. It's 25,000 lines of code right now. 25,000.
In total, so including virtual machine. So
Yeah, it's virtual machine, type checker, and scanner parser. Okay, thank you. So, yeah, okay, thank you.